Okay, ladies and gentlemen, you are welcome. So in this video, we are going to look at the concept of oogenesis. Introduction to oogenesis. So oogenesis is the process of egg formation in females. So ladies and gentlemen, in the previous video on gametogenesis, we talked about the aspect of spermatogenesis and oogenesis. So now we are going to look at this individual reproductive process. So starting with oogenesis, it is a process that involves the formation of egg in females, and unlike spermatogenesis, most cytoplasm is allocated to the large egg. So the cytoplasm is allocated to the large egg, and of course, the other products are called polar bodies, which do not develop into eggs. So actually, during meiosis of oogenesis, the only one egg or only one large egg is developed with small polar bodies. And those smaller polar bodies do not develop into eggs. So it means that at this point, ladies and gentlemen, you need to understand that during oogenesis, only one large egg is developed with 2 to 3 polar bodies. And those polar bodies do not develop into eggs. And as we can see clearly from here, this is the oogenesis where it started from the oogonium. And of course, from this oogonium, you can see we have the 2N, it is actually diploid. Then during mitosis 1 is divided into, of course, NN, and that is where we have, so aside from primary oocyst, and we have secondary oocyst, which divided into 2, and then the secondary oocyst will now undergo meiosis 2, produce 4 secondary polar body. So these 4 secondary polar bodies, as we can see, it will now further develop into one large ovum with 3 polar bodies. And these 3 polar bodies degenerate, meaning that they will not develop into eggs. So it means that at the end of oogenesis, only one egg is developed, and it usually takes place through meiosis 1 and meiosis 2. So then the next thing is distribution or cytoplasm distribution in oogenesis. So all cytoplasm and organelles are concentrated in the egg. They are all concentrated in the egg during oogenesis. So we should get this. So all the cytoplasm and organelles of the cells are concentrated in the egg during oogenesis. And then the polar bodies contain the minimal cytoplasm and eventually disintegrated. So they will contain the minimal cytoplasm, and then eventually they will be generated because they will not be developed into eggs. And this ensures that the egg, because all the cytoplasm and organelles are allocated to the egg, so it will ensure that there will be a sufficient resources, that is nutrient, for the early development. And as we can see, this is our egg. This is the egg where we have cytoplasm, nucleus, vitelline membrane, zona pellucida, and corona radiata. So this is the egg with its different components. So very importantly, let's look at the comparison with spermatogenesis. So usually, ladies and gentlemen, in spermatogenesis, 4 viable sperm produced from each meiotic product. So it means that at the end of each meiotic or meiosis during spermatogenesis, 4 viable sperm are produced, which is in contrast. In the oogenesis, it results in 1 egg and polar bodies per cycle. So for each cycle, 1 egg or 1 big egg will be developed, and 3 polar bodies will be generated per cycle. And the process, it reflects different strategies for gamete development in males and females. So these 2 processes, they are trying to show the different strategies that are used for egg development in males and female gamete. So now let's look at the differences clearly from the spermatogenesis and oogenesis. So in spermatogenesis occurs entirely in testes, while oogenesis occurs entirely in ovaries. Then for the meiotic division, there will be an equal division of cells, while in the oogenesis, there will be an equal distribution of cytoplasm, where the egg will contain the large portion of the cytoplasm and the fuller bodies will contain the minimal cytoplasm. Then the germline epithelium is involved in gamete production in the case of spermatogenesis, while in oogenesis, the germline epithelium is not involved in gamete production. Then what are the number of the gamete produced? So the number produced in spermatogenesis is 4, while for oogenesis is only one cell with about O plus 2 to 3 polar bodies. The size of the gametes, sperm is smaller than spermatocyst, while ova is larger than the oocyst. Then the timing. So the timing, that is duration, in the case of spermatogenesis is uninterrupted process, while oogenesis, it is actually arrested stages. It is arrested stages. For the spermatogenesis, it begins at puberty. That is when we reach our maturity. While for the oogenesis, it begins at prenatal, that is in fetus. Then in the case of release, sperm usually or is continuously released at any time, while oogenesis, it usually occurs monthly from puberty. And that is why, ladies and gentlemen, immediately after menstrual cycle, it means that the new eggs have been developed and released into the uterus. So if there is any sexual intercourse, so there is a likelihood at that stage there will be fertilization. So that is why some ladies, they are using this opportunity to not partake in sexual intercourse immediately after their menstrual cycle, because at that stage there is a likelihood fertilization can take place. So they usually take like 10 days or 15 days, and at that time the eggs might not probably be present at the uterus, that is which be ready for fertilization. Then end. When does it end? The sperm, in the case of man, it is a lifetime. It is a lifetime. It is a lifetime or lifelong. So usually, even a man of 100 years can still release sperm. It can still release sperm, so that's why it is lifelong, but reduces with age. While for the oogenesis, it terminates with menopause. So that is why there are certain age that if you are a lady and you didn't marry, because generally in the case of female, as the age, so there is a more chances for them not to conceive. We'll see that. Look at this. Generally, ladies and gentlemen, as we can see, males produce approximately 200 million sperm per day or daily. So a man can produce about 200 million sperm daily, while for the females, they can only produce one egg per menstrual cycle. So that is what actually happened in the case of females. And very importantly, ladies and gentlemen, in a ladies or in a female are born with a fixed number of eggs, because a female can have about 6 to 7 million eggs. And during fetal development, the eggs will be reduced to about 1 to 2 million. And then when they reach their stage of puberty, that is the age of maturity, the eggs will further reduce to about 300, 200,000. And over a lifetime, a woman can release only about 400 to 500 eggs. So that is why, let's say a lady can only release 400 eggs during her lifetime. So now you count that when a girl or when a lady reach her maturity, by the time she started her period, she will start releasing eggs. So let's say in a month, you only do one menstrual cycle. So you count 12 months. So after 12 months, it means that by then she definitely releases 12 eggs another year. So you keep counting. As you grow, the number of eggs will keep decreasing. That is why we have this diagram. The follicle number, you see, as you can see from here at birth, look at the number of eggs, 100,000. You see, at puberty, it will keep releasing. These are the peak fertility. You see, women are born with a finite number of eggs, and as she ages, her ovarian reserves diminishes. So you see, from the age of 0, 10 to 20 to 30, look at it, fixed fertility occurs. For ladies, usually the fixed fertility occurs during a woman's 20s, early 30s, and her fertility starts to decline rapidly from her mid-30s through menopause. So it means that a lady has a high chances of fertility between the age of 20 to early 30s, like 35. But between that 35, 50, there's a likelihood that she will reach her menopause, meaning that all the eggs will be exhausted. So therefore, she will no longer conceive because there is no even available eggs for the fertilization to take place. So that's why, as you can see, fertility keep declining as age. You see around 40, the fertility decline. Then around 51, they'll reach menopause, meaning that the eggs will no longer be fertilized. So you see a woman is born with all the eggs she shall ever have, starting with 6 to 7 millions during fetal development, then about 1 to 2 million at birth. So usually a baby girl, after giving birth to that baby girl, she usually came with about 1 to 2 million eggs at birth. And of course, around 300,000 to 500,000 by the time she reaches puberty. And then the number of eggs gradually decreased with age, with only fewer than 1,000 remaining at menopause. So this is what happened. So then now, ovarian structure and follicles. This is the structure of the ovarian follicles. So the ovary usually contains many follicles with developing eggs surrounded by follicle cells. So a follicle cells surround the eggs. We have a follicle cells which contain follicles, and the follicles contain a different eggs. So you see each egg begins as a primary oocyst during fetal development. And then these follicles support the growth and maturation of oocytes during organogenesis. So then what is the life cycle of a female oocyst? Each primary oocyst is arrested in for phase 1 at birth. And then a secondary oocyst is released monthly from puberty until menopause. So it means that each primary oocyst is usually arrested at for phase 1 at birth. Then the secondary oocysts are the ones that are released monthly from puberty until menopause. So this process results in the release of a mature egg approximately once a month. That's the life cycle of female oocysts. So you see before birth and the embryonic stage, then after fertilization, and then each one will be released. That is ovulation. The secondary oocyst will be released each month after puberty, which can be used for fertilization. So you see the oogonium before birth, there will be a mitotic division. Then we have the primary oocyst, which is arrested at or in a process of meiosis 1. And then we have a completion of meiosis 1 and onset of meiosis 2. And then after fertilization, then we have a secondary polar body. And this process is triggered by follicle stimulating hormones. So this is what happens. So it is actually the secondary oocyst that is released after every month. So ladies and gentlemen, this is where we are going to stop. This is the concept of oogenesis, and don't forget to subscribe and follow my YouTube community for more videos.